Hey guys, we're going to do 6.4, which is partial fractions today. Let me share my screen. Okay, so when we do these, what we're looking for is we're trying to find the integral of 1 over x squared minus 7x plus 12. Okay, if I try my normal integral strategies, so if I tried doing a u substitution, then I would get u is x squared minus 7x plus 12. If I figured out that u substitution, I would end up with the derivative being the 2x. So when I solve for du, I'm going to be stuck with a 2x and a u. And since u is x squared minus 7x plus 12, there's no way to isolate the x to put it in place of u. So a u substitution will not work for this, okay? So I can't take the integral because it's a squared, it's not just a natural log, so I need to break it apart somehow. So this is a new method of taking integrals. I can't do integration by parts because there's not an integral or derivative that would make that work. Okay, so what we're going to do is we're going to do a partial fraction. Going backwards from this, if I separated this back to a beginning problem like we did in Math 3, we would get a common denominator here, and then we would combine like terms on the top, and we'd end up getting a 1. Okay, so what we're trying to do now for partial fractions is we're going backwards. So instead of having all the terms combined, I'm going to split them up into 2 different terms so that I can take the integral 1 term at a time. Okay, so I've got this 1 over x squared minus 7x plus 12. So the first thing that I'm going to do is factor this. Okay, so that gives us an x minus 3 and an x minus 4. And I'm going to say something, we're going to call it a, was on top of that x minus 3 to make that be equal to the x minus 3. Okay? Or to be able to add the terms together, what I'm trying to say. Let me get this off the screen. Then I write the plus b over x minus 4. So if I got a common denominator here, I would get my x minus 3 and x plus 4. And I know that when I finish that, I end up with a 1 for my numerator. Okay, so the first thing we're doing is we're splitting it up and setting it equal to the original function. Okay, so if I did that here, if I factor this to x minus 3 and x plus 1, I would split that up and I'd go a over x minus 3 plus b over x plus 1 equals 5x minus 3 divided by both of them, x minus 3 and x plus 1. So what I'm trying to do is figure out is what is a and what is b, so that when I add them together by getting a common denominator, I get 1, or in this case, 5x minus 3. Okay, so we started off by factoring. We separate the fractions. Now I'm going to multiply this x minus 4 times a. So I'm getting a common denominator here. Okay, so x minus 4 is going to multiply by a. X minus 3 is going to multiply by b. And that's going to equal 1. Okay, do it over here. A is going to multiply by x plus 1. B is going to multiply by x minus 3. And that's going to equal 5x minus 3. Okay, so that's how you set it up. So now I'm going to say, I want one of these terms to go away so I can solve for the other term. So to get the a to go away, I would need this to be a 0, so that it's a times 0. What number, when you subtract 4, do you get 0? Hopefully you're saying 4. Okay, so if x equals 4, so let's let x equal 4. then I'm going to plug a 4 in here, and I would get 0. And then 4 minus 3 is 1, so I would get b, and that would get 1. So b would equal 1, okay? Now, if I let x equal, go back to the beginning, I want this term to be a 0, so I would plug a 3 in here. So I'm going to plug a 3 in. So if I put a 3 in here, I get 3 minus 3 is 0, and then 3 minus 4 is negative 1. So I'm going to get negative a equals 1, so a equals negative 1. Okay, so once we figure out a is negative 1, then I'm going to go back to this step right here, and we're going to plug in our a and our b. So if I plug in a was negative 1, and I get negative 1 over x minus 3, and b is positive 1. I'm just going to take the integral of that. So what I've done is I've said that this that I started with as this integral is the same exact thing as this, okay? This and this are the same thing, but we figured out what it was by doing partial fractions. Okay, so now I'm going to take the integral. So the integral of negative 1 over x minus 3 is the negative natural log of x minus 3. Okay, and then when we do it here, we get plus the natural log of x minus 4 plus c. So then I was able to take the integral, and that would be our answer. That's what we're doing. Okay, let's practice it again. So here, I'm going to let x equal something that will give me a 0 right here. So what would I plug in for this x so that when I do this number plus 1, I get 0? Hopefully you're thinking negative 1. Okay, we get negative 1. And so then I'm going to plug in negative 1. This will be 0. This is going to be negative 1 minus 3, so negative 4b. And then I plug negative 1 here. So negative 5 minus 3 is negative 8. Okay, when I solve for b, I get b is positive 2. Now I'm going to go start over again. Let x equal, in this case, 3. All right, so if I put a 3 in here, it cancels out. 3 plus 1 is 4, so we get 4a equals 5 minus 3 is 2. So a equals 1/2. Okay, I think this is supposed to be a plus. We're plugging a 3 in, so this is 15. So this is going to actually be 4a equals 15 minus 3 is 12. That didn't seem right. So we get a equals 3. Okay, so a is 3, b is 2. So I go back to my problem right here, and I put my 3 in, and I put my 2 in, and I take the integral. So if I did this problem, if I got a common denominator, and I times the x plus 1 up here and the x minus 3 up here, I would end up getting 5x minus 3. Hope you understand how this turns into this. Okay, and then we take that integral, and so we end up getting 3 times the natural log of x minus 3 plus 2 times the natural log of x plus 1 plus c. Okay. Sometimes you can put these back together and multiply it as 1 log, but where it has this would actually be x minus 3 to the 3rd power, and this would be x plus 1 squared, and I don't want to do that simplifying, so I'm going to leave it like this. Okay. All right. Example 3. So we factor then we set it up so that it's a over x minus 3, b over x plus 1 equals 2x minus 2 over both of them, x minus 3 and x plus 1. Okay, so I'm going to say a multiplies by x plus 1 b multiplies by x minus 3, and that leaves me with 2x minus 2. All right, so now I'm going to let x equal negative 1 so that that will cancel out. So that will give me negative 4b, and then negative 2 minus 2 is negative 4. So we get b is positive 1. Then we do the same thing here. This time, we're going to let x equal 3, so we get 4a. This one cancels out, and then 2 times 3 is 6, minus 2 is 4. So we get 1. So if I get 1 for both a and b, that's when it's easy to pull it apart. Okay, so I get 1 over x minus 3, 1 over x plus 1 dx. So if I take the natural log here, I get the natural log of x minus 3 plus the natural log of x plus 1 plus c. So because these are just single powers, the 1 and the 1, I can leave it like this, but you could also write this and multiply these two together, because when I add two natural logs together, I multiply the x's. So x minus 3 times x plus 1, we know from the original, is x squared minus 2x minus 3 plus c. So you could write that as this or this, either way, just so you understand how that could simplify sometimes. Okay, so here, I see, I'm looking at this, and I notice that the bottom is smaller than the top. So when the bottom is smaller than the top, what do we do? Okay, so the denominator is less than the numerator. When we have that, we do long division. Okay, so I'm going to do long division. So I'm going to go x squared plus x minus 2 divides into x cubed minus x plus 2. Be really careful here, because this goes x cubed and there's a missing x squared. So I'm actually going to write it there so that that's easier to see when we finish this. Okay, so x squared divides into x cubed, x times, and then I do the x at the top multiplied by each number on the divisor. So x cubed, x times x is x squared, x times negative 2 is negative 2x. Remember, we're subtracting, so this is minus, and this will be plus. Okay, these cancel out, and I get negative x squared plus x plus 2. So now we're doing the same thing again. We're going to say x squared goes into negative x squared minus 1 time. So that gives us negative x squared minus x plus 2. But remember that we have to change the signs. Okay, so when I change the signs, I'm going to be left with plus, plus, and minus, which gives me a 2x. Okay, so if I write this as an integral, I've got my x minus 1 plus the 2x that was the remainder is divided by x squared plus x minus 2 dx. Okay, well, I can take the integral of x. That's just 1/2 x squared. And I could take the integral of minus 1, but can I do the integral of this? So if I do the integral, or if I said u is x squared plus x minus 2, then I get du is 1 over 2x. And the 2x will cancel, right? So then we can just change that into our u substitution. Let's do it with partial fraction and see what happens. So x plus 2 and x minus 1, a over x plus 2, b over x minus 1 equals 2x over both of them. Okay? And so now what we're going to do is cross multiply. We're not really cross multiplying. We're getting a common denominator. But when we have an equal sign, the denominator cancels out. Okay, so this I'm going to let x equal 1. So let x equal 1. So this is going to be 3b equals 2. So b equals 2/3. Okay. And then we do it for a. So we're going to let x equal -2 this time. And we get -3a equals -6. Not -6, -4. Because we're doing -2 times 2. So that's -4. And so a is +4/3. So we get the +4/3 and the +2/3. So if I write this all together, let's scoot this up a little bit. Okay. If I write this all together, I've got the integral of x minus 1 plus 2/3 divided by. Now remember, a is 4/3. So I'm actually going to write 4/3 first. The order doesn't matter, but I want to follow the same thing. So 4/3 times x plus 2 plus 2/3 times x minus 1 dx. So now that I have it like this, I'm able to take the integral one term at a time. Okay, so that's going to equal 1/2 x squared minus x plus 4/3 times the natural log of x plus 2 plus 2/3 times the natural log of x minus 1 plus c. That's pretty much as complicated as it's going to get, where you had to do long division first, and then you have to go back and plug that in. Okay. All right. So in example 5, it's having you do the integral of 4 different things that look similar. In example 6, it's having you do the integral of 2 things that look similar. They're called lookalikes, so that you can see the different methods that we use for different things. Okay. So I want you to pause the video for a minute and do these 6 problems, and then unpause and see how you did. Okay. So hit pause and do those problems. All right, welcome back. Let's see how you did. So here I've got 1 over 1 plus x squared. I'm taking the integral of 1 over 1 plus x squared. Hopefully you recognize this as the arctangent. Okay, now arctangent has x over a, and then you multiply by 1 over a, but a in this case is a 1. So you just get arctangent of x plus c. Okay. All right, for this one, I've got 1 over 1 plus x, which is just a natural log. So the natural log of 1 plus x plus c. Okay. On this one, I have an x, so I can't do my just natural log because I have an x up here. So I have to do a u substitution. So 1 over 2x. Okay. So this x is actually our hook on, and it's going to cancel out with this one, but the half is not going to cancel out. So I've got the integral of 1/2 1 over u. So 1/2 times the natural log of u plus c. Now remember, u was x squared. I forgot the 1 plus x squared. So this is going to be 1/2 times the natural log of 1 plus x squared plus c. Now, with the 1/2 there, I could bring that up and write it as a square root if it was multiple choice and they had to go further. Also, x squared plus 1 will never be negative, so I don't need absolute values. I could do parentheses. Okay? All right, and then the last one we have is 1 over 1 plus x squared. So let's see if I do a u substitution. Du is just dx. So I've got the integral of 1 over u squared, which is the same as u to the -2. Okay, when I take the integral of u to the negative 2, we get negative u to the negative 1, because we're adding 1 to the power, plus c. So negative 1 plus x to the negative 1 plus c, which is the same as 1 over 1 plus x. So those are our 4 lookalikes. So see how similar they look and how different their answers are. So you have to be really careful when you take the integral that you're not leaving a u or a hook on behind. Okay? Integrate the following 2 lookalikes. All right, so if I'm taking the integral of 1 over x times the natural log of x, I'm going to try a u substitution of the natural log of x. Remember, we can't take the derivative of the natural log of x. So x times du equals dx. Okay. So I've got the integral of x times 1 over x times u du. So the x cancels out. Okay. And then 1 over u is the natural log of u plus c. And then that's the natural log, and the u value is also a natural log. Okay. All right. And then this one is natural log of x over x, so it's a little bit backwards. Okay, so if I do a u substitution, still do the natural log of x, then I'm going to get du equals 1 over x dx, and x du equals dx. So now I have u over x times x du. The x's cancel, and we're taking the integral of u, which is just u squared over 2. Natural log of x squared over 2 plus c. Okay, so those are all of the different types of lookalikes that we've done. And we've learned partial fractions now. So you're almost to the point where you can do all your derivatives and integrals. We have 2 more sections, and then you will be done.